questions we did these days? How was it? Any challenge? Did we learn something? Did we do it? If you don't do it, you're not doing yourself good. Though. If you didn't do it, you're not doing yourself good. If you're having difficulties and you did not speak, you're not doing yourself any good. I saw little to no questions on the group chat, and I was like, these guys are good. They really get it. So does anybody have any challenge? Speak up, let me know so that we can address it quickly and then go straight to what we have today.
Hello, is it the lab?
Yeah, the lab I gave. Yeah, the lab. No, not the labs on your account. I gave an assignment, right? A bi-weekly assignment on the group chat. So I want to know.
Okay, I thought it's lab.
Anybody, any questions? Okay, but did you have any issue with the lab?
Not yet.
Okay, not yet. I hope it remains like that, though. I hope it remains like that. Yeah. So any questions? Any questions? Any questions? Or any observation? Anything you think? Yeah, go ahead.
Yes, sir. So I've been trying to download Cisco Packet Tracer from the course material from the module, but it's not working. Like to start downloading, and then all of a sudden to tell me maybe it was disconnected as a result of network. But if it eventually connects back, it will fail. Like the file, they'll tell me the file is not on my system. I've tried downloading like over 6 times.
Exactly.
It's not showing on my download.
Exactly. That just defines your problem. For the fact that your network disconnects you, that's the problem. So what you can do to help yourself is to clear your cookies.
Yes, sir.
Right? Clear your cookies,
okay.
And try again. Because
Right,
these systems have a way of remembering your previous state. So if the cookies are not cleared, it might still have issues. So just clear your cookies and try again. But don't stop trying.
Right.
Your network is playing a prank on you. Yeah.
Thank
you. Good evening.
Yeah. Any more questions to talk about? We have. Yeah. Good evening.
Please. Good evening.
I didn't hear you. Go ahead.
Please, I went through the CyberOps, where the modules and all that. So I came across labs under each modules, and I don't think we have done any of them. It's just you using your own virtual or Linux machine to like display one or two things that when you're trying to explain, but like we not worked on the lab properly. So I was thinking maybe there be a folder where those labs are, where we can have access to those labs and then work according to the instruction given to us using the CyberOps. I don't know if you get what I'm trying to explain.
Okay, so let me try to rephrase your questions. So you notice that there were labs on CyberOps because CyberOps is majorly a practical.
And we've not done anything according to the labs. The labs we usually do is maybe when you're explaining, you just practicalize it using your own this thing. Like
it's not done.
Yeah, because I believe Cisco has their own, like from the instruction, you just go through it for you to understand the particular module correctly. So, but when it comes to this side, you just go to your own terminal, just shows from what you're explaining, but we don't work on those labs. So I'm thinking if there are maybe a folder or file where those labs are being downloaded, or maybe anything, or maybe if we're going to work on the labs, maybe it'll be like we're having classes today, then by the next time we're having the class, we'll work on the labs that is attached to that particular module. By so doing, we'll be able to understand it accordingly, because when you're explaining, you open a terminal, you open this one. Sometimes, I don't know for me, I don't know for others, but for me, sometimes it's confusing, right?
Yeah. I get it. I understand. Yeah. So let me explain something. We have classes only twice in a week, and then to make it easier for everyone, we don't want to extend classes beyond 2 hours. In fact, we don't usually have the luxury of time because we also have people who are training on CCNE, right? The essence of the lab, the idea behind the lab is that you should work on it by yourself. And we have also factored into place that you will also experience difficulties. It's part of the thing, because when I was learning, I experienced difficulties. So if you follow the instructions for the lab, each lab, because we're going to have a lab on this call, and I don't like doing labs on the call. I've said it before, because it takes much of our time, and we have to just manage and do everything in 2 hours, right? So while you're working on your personal time, doing the labs and everything, if you have any question, when I mean any question is any question. I don't know where to see command prompt on my computer. It's a question. Please, we have a WhatsApp community. Drop it there. Right? You drop it there, you will sure get guides. If your own is that worse that you don't even know how to do anything, maybe I can just look at you and say, okay, let me assist you in a way. Right? If I see that your questions is a bit more fundamental, then I can know, okay, how to assist you in that way. So the one thing you should know is that when you're joining cybersecurity at the particular stage, nobody's gonna be teaching you anything again. Learning, you own your learning, and you own your learning journey. Is that clear, Zara?
Yeah. Okay.
So please, while the lab instructions are already there on the CyberOps portal. If you see the lab instructions, sometimes it can be confusing. I get it. So nobody has ever died from asking questions. Abi, have you seen anybody that died because he asked questions?
No,
I just want to
just
know.
saying. Just for
Yeah,
people that don't have the
yeah.
knowledge of it.
Yeah. Your observation is okay, is correct. I get it, but please don't sit in silence. Don't sit in silence. It has never paid anybody. You don't know anything. You are quiet. I've been in places where I went to, about 15 of them. Do you understand? Everybody said yes. I shouted no. I don't understand. I shouted no. And people were like, you would have. I said, oh God, the question they asked is, do I understand? I don't understand. That's me. And that's how it has brought me thus far. There's no, I don't know. One of my friends said there's no pride in, let me not use that English. He's a very funny person. So please, that is clear. Please, if you have any question, I keep shouting this. Bring it on the group chat. Don't come and post links to group or come and post free data. Please, we don't allow that. Nobody's sharing free data anyway. Okay. Any more question? Someone said he does not have a laptop. I'm afraid. I don't think it's work.
Good
Yeah,
evening,
good
bro.
evening.
Yeah, this Ahmed
My name
Murtaza
is
speaking.
Adekunle. I just want
How many
to.
persons are speaking? Hold
Are you
on.
hearing
How
me?
many persons are speaking? Adekule, go on.
Um,
Adekule, go on.
all right. So, just the same thing the lady asked, but I just want to make a clarification. The lab, when I saw it, I thought it is a kind of assignment, and in fact, I have done two already, keeping it that okay, where are we going to submit? But up to date, I didn't see anything. In fact, I intended to like ask the question. That's when he asked. So I just want to make clarification. Is it for our own consumption individually, or are we going to talk about it generally, or any? What is it?
Yeah.
What?
Okay. Here's the idea. At the end of this course, you're going to write an exam. One, you're going to write a very serious exam, and please don't fail it. This course is a free course, so you should not fail the exam accompanying it. Trust me, if you miss any lab, you're going to have issues, because this progressive learning we are doing here, you will have issues. And I'm not saying you doing the lab just to pass the lab so that you get understand what is going on in the lab. Very important. Very, very important. Also, we have our own, all the projects I'm giving you for now, I'm not asking you to submit it, but I will ask you to submit one. And that's going to be a capstone project. And that will also determine whether you get a certificate from us. So please, follow through. It's going to be a serious project.
I have one thing again to say. Please, if you're sending maybe an assignment on the group chat, I think there should be another group chat for announcement, because by the time we come to know, because me, I didn't even see it because there were a lot of messages.
Messages, right?
There's
Yeah, noted.
Another platform, so we can just go there and see the assignment. Then even if we now have a different group chat where we can have a communication, maybe we don't get to understand things or something.
Okay.
No,
okay.
What was it called? It is community now. Community. It can be posted on announcements, different from the general group
Noted.
now. So once you check your
Yes,
assignment,
yes, that's
all
what
right.
I mean.
Yeah, we'll take that into consideration.
Okay, sorry, please, sir. What I wanted to say before Mr. Adekunle came into discussion was that Tawa Ibrahim was complaining about downloading Cisco packets. So maybe I have a link to where you can directly download it. So if he tries it again and you cannot download it, maybe you can signal on the group there. I can send the link. So for anyone that wants to download the Cisco packet.
Okay. All right. Yeah. I think there's also a link to download it. Please make sure your link is genuine. Don't send link that somebody's money will miss. So my hand is not there.
It's genuine, sir. No, once I sent to you, confirm what you will confirm before clicking on it. There's no efficient.
Yeah.
I was just joking. Yeah.
Okay.
I was
Is
joking.
Murtala Murtado on the Cybersecurity Unicorn?
Yes.
I do. Okay, so
All right.
I will chat you later, sir.
All right. Thank you so much, Muritala. Thank you so much. I really like that. Okay, so let's go straight to what we have today. Someone saying something? Okay, we'll move on. Yeah. So today we're going to talk about protocols in networking. Talk about how data moves from one particular place to another in networking. So I just want to give us a foundational understanding. Usually, how these things work is that, for example, you want to send a message as I'm talking to you now. I just want to explain what's going on. So you all can hear me from wherever you are. Yes, sir.
Yeah, share your screen.
Okay, no, I've not started sharing my screen. Okay, I've not started sharing my screen. Once I go to the portal, I'll share it. Yeah, I will do that. And is this class recorded? Oh my God. Okay, yes, it's recorded. So, okay, let me share my screen.
It's being recorded. Please, sir, I want to quickly say something. Please, if you have any further questions, please we should pen it maybe to the end of the class, because time is already going. Please, I urge everyone, please.
No problem. So, you can all see my screen. Can you? I believe you can see my screens.
Yes, you can.
Yeah, okay. So, I just wanted to explain how these things work. So, usually there are two types of signals. We have what we call analog signals and what we call digital signals. Distinct type of signals. When we're growing up, when we started learning electronics newly, we are always doing things have to do with ADC. ADC means analog to digital converter. DAC means digital to analog converter. So these two concepts or these two things are very, very important. So every signal we see in the world is either analog or digital. For example, if someone is talking, it's an analog signal. So the question now becomes, how do we send the analog signal over long distances? Right? Especially in telecommunication. That's where digitizing the signal, what we call digitizing the signal, comes into play. And digitizing that signal is just a process of changing the signal into what we call ones and zeros, highs and lows, on and off, ups and downs. That's just what it means. So analog signal can have multiple states, but digital signals is either up or down. Two states available. It's either high or low. So usually when we're making calls, in fact, that's what's happening currently now. The process is called modulation. Modulation. Right? So now it will just take that signal and put it through a pipe, what they call a higher signal that has higher frequency, and send it over via a channel. And that channel has what they call a demodulating network that removes the higher signal and picks only the correct information. That's how it basically functions. So the same thing kind of happens when we are doing about communication protocol or network protocols. Now, why is network protocols very important? Initially, when there was a rush for when technology became a thing in the 1970s, in the 1980s, when big technology companies like Microsoft started, IBM, I don't know if any of us have heard of IBM before. IBM, the meaning of IBM is International Business Machines, was one of the in fact, I think it's the oldest of them all. It started producing punch cards and all those machines. So IBM got into the market. Microsoft came in. Before you have what you call the Facebooks of our day or time now, and the Twitter and all that. Before all these things became a business thing, they were mostly an issue of solving technological problems. How do we make life easier? How do we make things faster? So the world over the years had conquered the issue of sending signals from one point to another. What the world was able to do initially was, okay, can we send voice from one point to another? Then in this popular lab in the United States, that problem was solved. What's that lab again? I'm trying to remember the name of that lab. Bell Labs. That problem was solved when they invented the telegraph or fax machine, telegraph, and they were able to send the first message, and the whole world was like, whoa, this is brilliant, and all those kind of things. They invented that. That was working. Then, as things came on, there was a need to implement, to invent. Then the first computers came about. They are still in the business of how do we send message from point A to point B. So then the Microsoft come with, IBM had their computers then. I think IBM was the king then. IBM said, okay, because our computers need to talk to another computer, another place, we need to have what they call a method of talking. That's what they call protocol, a method of understanding. I don't know how many of you used to watch military movies. You hear the soldier saying, tango on your 6. Maybe there is a guy that is doing surveillance, something. Tango on your 6. I don't know if you understand those lingo they are using there. That's military lingo. On your 6 means behind you. On your 12 means in front of you. Maybe at your 3 o'clock means by your right. At your 9 o'clock means by your left. So if you understand how war clock works, you understand what they are saying. So these are military lingo. So the same way it happens, computer talks to another computer via protocols. It's just the way they talk. Protocols is a system by which two computers can talk. Now, IBM was making their own machines. IBM had its own protocol. Windows was making their own machines. Windows had their own protocol. Dell was making their own machines. Dell had their own protocol. The problem there was that an IBM computer cannot speak to a Windows printer, because the Windows printer does not understand the protocol from the IBM machine. Now, if you are careful, you see what that meant. If I started a company, I have to buy and I want to use IBM. IBM must supply everything. What if I don't want IBM to? What if I want IBM to give me computers? I don't want IBM to give me printers. Maybe IBM printers are too big and my office space cannot take it. What if I don't want that? These are things that came into consideration. And then IEEE and other organizations came together to standardize all the protocols that we use in communicating. The Ethernet protocol came into place, the IP protocol came into place, the ICMP protocol came with a lot of networking protocols are currently in place. Some of them, they were using the protocols before, they saw some security issues, they improved on the security issues and deprecated the old protocols. So the same thing we are using protocols for browsing is called HTTP protocol. The standardized design is that HTTP protocol works on a port 80, but it does not mean that you cannot configure your own on another port. But standard procedure that it works on port 80. Then for the other one, if it's a secured protocol, it works on port 443. So these are the things. Protocols are what is needed when computers communicate. And these days we've advanced. I'm proud of what we've done, right? We've advanced to the extent that we can now, communicate via long distance. Via a meeting like this, where all of us can, see ourselves, can hear our voices, can talk to ourselves. That's the beauty of advancement, right? So before all those days, it was not so. You want to have a business meeting, you have to, enter ship. If your boat capsize, if it does not capsize, but these days you don't need that. You can stay in the comfort of your homes, like most of you are now. Some of you might be on the way now, right? And be listening to me. It's because network protocols are working together, right? And some of you can be using a different computer. It does not matter, because there's a standard method now that all computers, no matter the manufacturer, is using. Cisco was one of the people that started networking. So old Cisco method of networking was very crazy, but Cisco had to drop it when there was an international standard for networking. So if you do something about CCNA, you will understand about Cisco's protocols, especially in their switches and their routers. You will understand it. But then that's not the point of this course. So I'm just here for us to just understand this. So before we understand how networks talk, we have to talk about sizes of networks. There are different sizes of networks. All networks are not the same size. We have small networks, usually small and larger networks, but I think this course gives us more classification, right? So a smaller network, small home network, for example, in your house, you don't want to, you want to you have a computer upstairs, you have another computer, or in your room, you have two computers in your room, and you want two of them to communicate without necessarily using the internet. It's possible. You have to build a network. Maybe then they have to talk to themselves through an Ethernet cable. And those ones are very fast. You can send large files over the Ethernet cable to the other one. It works. Then small offices and home office networks. So for those of us that want to, become orgas, I want to build companies like me, maybe you can build a company and my office will be upstairs, and let's say my sister will have another office downstairs. It's a home office, and all that. So maybe I want to send a file to her downstairs. There should be a communication. There should be a way for me to send a message from that top down straight without going to meet her physically. Then there are the medium to large network. So these are the ones we see in places like schools, a CBT center, depending on the size of the school. An office, a company office, where you can have different connected via different means. Some connect via Wi-Fi, some connect via Ethernet cable. So these are different means. Then we now have the largest of all network, the worldwide network. So this is a system of interconnected servers that connect all the computers worldwide. So this is a very, very important decision to know. So when you know the size of what you're dealing with, you know how far you can go. Then we also have what we call client-server communication. I think we've talked about client and servers before. So usually we have three major types of servers. We have a file server, we have a web server, and we have an email server. Their name just tells you what they do. So a file server is just like you have a computer, a server that you keep files on top inside the server. There, and any file you want, for example, in your organization, any file you want people to gain access to is in that server. So maybe you can put a protocol for people to access that server. Maybe you can say they should use what they call FTP. FTP means file transfer protocol. You can say, okay, and FTP is on port 21. You can say, okay, before you connect to this thing, you must use FTP to connect. Before you must log into our. So if you go to companies, they can just tell you how they might do it is that they can tell you we have a secure portal for you to access any file you want. Because you can imagine that if somebody wants to access a file, they are telling the person to use FTP. Somebody that studied economics that does not know anything about computer, the person will not understand what you're saying. So the technical people in the company will just abstract that layer in such a way that if you click a button, that button sends the command, asks you for your username and password, and when you put it, you access it. Either to upload or to download. It does it seamlessly for you. But the technical people can use FTP with themselves and do the same job. So that's how it works. Then we now have a web server. A web server is just that allows people to run web pages. It's a server software. So there are many different types of web servers. Popular among them is Apache, right? Apache. In fact, I'm even building a website currently using Apache. Apache and Nginx. So Nginx is quite is better these days because Nginx has what they call a proxy to redirect traffic and drop off malicious content. Then we also have email server. From the word email server means that all the emails pass through a particular server. Depends on how it's configured. So companies usually have like 3 different email servers. And some companies don't want to carry that load. They can use managed hosting like Zoho and all that. They can just say, oh yeah, these people manage our email, Zoho manage it, and that's all. The essence is that there are ways that those managed servers provide those email management to you that helps you. So for example, there are companies that have strict security on their own end. If you do not have security, maybe your DMARC is bad or your DNS security is bad, if you send an email to those companies, if for example, if you at the other end, your DNS security is bad and you send an email with your company's domain to my own that has a strong DNS security, my own will tell me that this email is from a malicious end. And a CEO will not like to see this email from a malicious end from a potential client that he wants to do business with. It does not speak well of you. So these are things you need to watch and take charge of. So these are the main types of server. Then we have typical sessions. Okay, sessions. They're just trying to tell you how it can be used. It can be used by students. We talked about that. It can also be used by gamers and surgeons. Very, very important. So in some companies, they implement a policy called BYOD, bring your own device. Right? Carry your own laptop and come. My company was doing it then. So when you bring your own laptop and come, then we'll now see how to help you. And they will now create different layers of security before you're able to access the company's internal network. But if they give you company's laptop, you can't do anything with company's laptop. As simple as Spotify is, the admin policies is so strong that you can't even hear your favorite songs on Spotify. You can download Spotify, nobody's holding you. But once you put play, to not work. Very funny occurrence. I experienced it and I was just laughing. Now, tracing the paths. So one thing you have to understand is you have to understand how traffic flows. Tracing the path. So there's a tool called, I think we did that. I was trying to do that today. If you see, when I was troubleshooting my outage today, I knew I had issue with WebEx. You can see I was already doing something with TraceAt, netaccount.webex.com. I was trying to trace what's going on. You see, it started here, it went here, it timed out, it went here, it went here, it went here. It got to London, it reached here, it got to this place, it got to London again. I will explain all these things. It started timing out, time out, and the request kept on timing out, meaning that at this point, there's a particular server that is supposed to have gotten to here, and this server was down before it finally got here. Now, if you calculate all the time it took, I'm in trouble. So when it takes that long time, your browser will simply drop the request. So tracing the paths, we use what they call TraceAt. So if you are using Windows, you say TraceAt. So for example, we want to say, let's assume we want to trace something as simple as Cisco.com. You can see we use TraceAt. Just write TraceAt Cisco.com. So this is going to just be tracing the network gradually. If you are watching, you see it's just going gradually. So these are tools you need to know. These are tools we need to know to trace the paths, right? From where it's starting from to where it's going to. So while that is running, let's just keep on talking. So there are different ISPs. Different ISP means Internet Service Provider. Different ISPs. So we only have the tier 1 ISPs. So these are the ones you know. MTN, I don't know the country you are from. I don't know the one that's more prevalent, but I think MTN has a big stake in Africa as a whole. MTN, mention Airtel, Globalcom, which one again? Etisalat.
Yeah.
Etisalat. I think Etisalat have changed name how many times now? Etisalat to T2 Mobile to what else again? They're just changing their name up and down. So, but then it's okay. But if you know all these networks, which one do you think is the strongest network? I want to ask. Let me know. Those that know these networks very well. Between MTN, MTN is the strongest.
And
Airtel, So if I tell you guys that Glo is stronger than all of
MTN is
them,
the strongest, but that
if I tell you guys that Glo is the strongest network, I know you will not agree. And it's not because I work with them.
the traffic on Glow is too much.
Why? Why is traffic too much? Have you ever asked yourself?
I don't know, but it used to slow or it will not function very well at times. That's why we don't use it at times.
Okay,
Because you
someone
use
said Glo is the strongest till it starts raining. Okay, that's the funniest thing I've had today. Okay, let me tell you something. So somebody's right to say that Glo has the highest traffic, and Glo has the highest traffic because the MTN you are saying is the strongest, rides on Glo. The Airtel you are saying is the strongest, rides on Glo. There is no network in Nigeria that does not ride on Glo. In fact, the day you're not able to access YouTube again, whether it's in MTN or Airtel or whatever, now Glo cause Glo is the problem. So you have to be careful. Glo is still the strongest at the end of the day. The other thing is that MTN has more subscriber base in terms of people like us now that use MTN, that use Glo and all that. Glo has more subscriber base. So you people are just like, oh, Glo. Glow does not send all those things. So Glow is after making the big money, big millions of dollars and going out. They don't care what you think, actually. So I'm just saying this, right? They are more profitable than MTN. They are more profitable than Airtel. They're just silent team of people doing their business. So if MTN has a subscriber base and will ride on Glow and MTN pays Glow does not care. So now you see that in a way it boils down to decision making, leadership, decision making, and business decision making. So I hope that's clear. At the end of the day,
Sorry,
Glow is
boss.
still more powerful. Yeah, go ahead.
No,
Please,
no,
please,
please come again. I didn't get the point.
You didn't get the point? Somebody is asking a question. Let me know who is asking the question. What exactly is going on? Let me know. Before I go over to
How Glow is the strong in Nigeria to understand you explain.
Don't worry, you watch the video, you will hear what I said. Just watch the video. Wait for that side where I said about Glow. You will hear it. All right? I don't want us to waste much time. Okay, so let me go to my screen. Let's see our result of TraceAt. Okay, so we still had some requests that timed out. Now we see at this particular point, we got to a particular point where we have Cisco Edge 5 at Dallas. It's clear, right? Cisco Edge 5. We got to a particular server here, and remember we are tracing. When we use the word TraceAt, we are tracing how does my traffic move from my current IP address to the final IP address. And what's the final IP address we're targeting? Remember, we're tracing to cisco.com. And cisco.com has an IP of 72.163.4.185. The first one is saying over a maximum of 30 hops. I mean, you can edit these hops to how many it can be, but that's not an issue. Over a maximum of 30 hops, meaning that over a maximum of 30 servers. So jumping from this server to this server to this server to this server to this server. If it fails at any stage of this, it's going to try again. That's what's happening here. It moved here to that. This is where it left. This is my original server. You know, when you are moving, when it's leaving your computer, it's going to use your ISP IP address. So that's I want to say this for those of you that want to get jobs on foreign companies. You cannot just use your normal IP. You have to write to MTN. You have to reach MTN and tell them that you want your own personal IP address. So MTN is going to sell an IP address for you only and only you alone. So only you will have that public IP address. So anytime you want to connect to that company's network, they have saved that IP address for you. So anytime you are browsing with MTN, the IP address people will be seeing that belongs to you is just that your own public IP address. That's what some of you are using when you go to use VPN. You are just simply using someone's public IP address. That person is receiving money for it. You are paying subscription for VPN. That's why you are paying subscription for VPN in per month terms. That's how it works. So this is the ISP IP address. It's going out. It's just showing you all the servers it's going through. However, if you want to know where all these servers are, they're not difficult. For example, I can just pick up this IP now and say, okay, control this thing and then come over to my browser and then just type, I think there's a popular site we used to check. What is my IP address? Yeah, what is my IP address.com. If you go to this site, if you paste the IP address to show you the location, it should show you the location. So normally if I put this, it will show me my own IP address, which is not what I want to do. Anyway. So if I put the IP address now, I just got now and say, okay, see, it's showing me my own IP address. But this is not my own IP address. You can see MTN ISP, MTN Nigeria Communication. MTN is giving me an IP address that is in Ondo State. Meanwhile, I'm in Lagos because I did not pay for any IP address. So if I want to do any business and I tell them I'm in Lagos and they're seeing my IP in Ondo, they'll be like, where exactly are you? So if I post this IP address now and say search, it should tell me where this IP address is. Hold on. Should search. I think I pasted an IP address. For IP lookup. Okay, yeah, IP lookup. So go to IP lookup and you put the IP address to tell you something about the IP address. Now, why is it not showing me this? Another site that does this. I don't like all this stress. You show me my IP. Okay.
Can you
But
zoom out
then
the place?
the point, I'll check that later. I don't want to go through deep. There are different ways. So you can also find, I know it's not hard to find it anyway. Just you can also find it. So there are all this IP address is just showing you traceat. It's just showing you how this thing is routed. And it landed here finally, our destination, where we wanted to go. That's the main idea. Now, if you notice now, it took long before it's able to trace it. I just want to show you why your location matters when you're doing all these things. Let me look for any popular Nigerian website. Who knows any popular Nigerian website? Many popular Nigerian websites. A website I know that is hosted in
Use
Nigeria.
Nairaland, sir.
Okay,
So use
Nairaland. Nairaland.com, right? Let's try Nairaland.com. So if we say traceat, we'll know whether Nairaland.com is actually hosted in Nigeria. All right, so let's see. You can see it has shown you the IP address of Nairaland.com. This is the IP address. So let's see. We will now know information about Nairaland.com. You can see this is where it is living. This 10.9.197.1 is the router, is MTN router. This one again belongs to MTN, the router. So these are things you have to be noting. You have to be noting it. So it left one MTN router, two MTN routers, three MTN routers. I think it has gone to the fourth. All these things are just the parts my network is taking to go out to find where Nairaland.com is. So if Nairaland.com is hosted in Nigeria, that should not be a problem. But I know one server that is hosted in Nigeria anyway. We'll use that one. We'll see. What I'm trying to prove to you is that if it is hosted in Nigeria, the path should not be long. That's just it. The path should not be long. It should not take all this time it's taking. So obviously, the first telltale sign that it is not hosted in Nigeria, you can see now. You see a server, it's showing you a server in Atlas, somewhere else that is in London. So Nairaland.com is not hosted in Nigeria. The main server is not here. It's somewhere else. And they are routing their traffic through Cloudflare. These are things you have to watch, especially when you want to do investigation in cybersecurity. And these are telltale signs that or these are things that hackers or malicious people use so that you will not find the actual servers. Once it's routing through Cloudflare, forget it, you can't find them. So this is it. It has reached where it is going to. But this one took us a long time. There's this site I'm trying to remember. If I do this traceat now, I will do another. We'll move on. Let me try to remember. There's this site. I know that the server is hosted in Nigeria. I'm sure of that one. In fact, I configured the site, so I know. I know where the server is. I've seen the server physically. So let me look. I know the IP address. Okay, I've seen it. So let's see how long it will take us to reach this server. Traceat. If we did not set up a firewall to block this. So So now I put only the IP address. You can see now, this is a global com server, Glow World. It's obvious. It's just telling you, oh, this is a Glow World server. So it's going to trace the path to that point. Let's see how long it takes us to get there. You can see that the times are relatively smaller. It's taking its time, but it's going to get there. And all these things is because it's routing over MTN network anyway. So now when you are doing on Linux, you will not use TraceRoute. You use another tool called traceroute. Right? Use another tool called traceroute. So traceroute is going to help you. Traceroute is going to help you. You see, you look at the time now, it's very relatively small. Relatively small. It has landed on the server. It has shown you very. So the name of the server is also obviously there. It's a Glow server. I'm the one that did this one configuration myself, so I know where it is. I know where it is physically in. But then that is just one of it. So you must know how to trace the path. In fact, it's one of the tools you use. TraceRoute. Then if you are doing with on a Linux machine, you will not use TraceRoute. You use another tool called traceroute. You will see it in the lab, right? So in the lab it says traceroute is for Windows system, while traceroute is for Unix. So if you are on your CyberOps machine, you will use traceroute. If you are on normal Windows, you will use what are they calling it? TraceRoute, normal TraceRoute. So we have the listing. You have to use ping. So ping is just like ping. The ping has a full meaning. Let me check the full meaning of ping. Ping. That thing is saying, ping became. Let's see the full meaning of ping. It has a full meaning. Something internet grouper. You can check it. Of ping. You can always check it. Packet internet grouper. Exactly. That's the full meaning of ping. So you can always browse about and check about it. So when you are using ping, you just saying, asking, are you up? That's what you're asking ping. And this command, especially on your listening, ping -c4 means send 4 packets. So ping means you are talking to a server. Are you up? The server say, I'm up. So that means server has replied you. If the server does not reply you, that means server is not up. So these are things you have to know. So if somebody wants to attack your server and the person press a ping and knows that the server is up, the person can attack it. However, you can put a firewall on your server. And that firewall, you tell the firewall, if somebody pings you, don't respond. That was another security measure. But it does not mean we can still bypass that one. We will know. We will know once there's a firewall. We will know that there's a firewall there. But that one is another day for another class. So you're saying this ping -c4 means ping this server 4 times. We can do that on the Windows. You can just say ping. So I will not do that -c. I'm not sure -c does not work on Windows. -c should not work on Windows. I think Windows has its own. Yeah, it's not on Windows. Okay, it requires administrative privilege. For example, we can check manual ping. Okay, I'll say ping -help. I've always said you can always find the help, right? This T means continuous pinging. -a means resolve address to host name. So in Windows we use -n, right? In Windows we use -n, but in Linux on your CyberOps you use -c. So in this case, you can say ping -n 4 counts. Say Cisco.com. Windows will ping it 4 times and tells you. You can say ping let's say 6 times. Windows will ping it 6 times for you and tell you whether it's up or not. So at the end of the day, you see it. Packet sent. How many packets sent? 6 packets. How many received? 6 received. Was anything lost on the way? None was lost. What's the approximate round trip times in millisecond? It tells you. Round trip means how many times it took to go round to get back. It will tell you everything. So these are important information. So if you learn how to use ping to ping a server, then you can also learn how to use. Then you can also use from ping and traceat to understand how traffic is flowing. Very, very important. So it says it's giving you information. It says the first output line displays the fully qualified domain name. So that is when it is pinging. So I think the ping is quite different from Linux, right? So in Windows, we have to do, I think we have to do a -A. Let me see if a -A works. A -A does not work here. Okay, let me put it after. Let me -N6 say -A cisco.com to resolve it to its original name. Okay, but please do this lab. Do this lab on your CyberOps machine. Very important. Do this lab on your CyberOps machine. So it follows by the IP address. I've always said it is showing you the IP address. Of course, results will differ. Please, when you are doing this on your machine, that they got 13 milliseconds does not mean you should get 13 milliseconds. It does not. The main thing is that you understand how it works, right? So they say tracing a route using a remote server to a remote server using traceroute. So we still use the same traceroute command. Traceroute www.cisco.com. It shows you the route. We've done that here, but in Windows, we are not using traceroute. We are using traceat. 2 different things. Also, one good thing about using it is that you can also forward your result towards a text file. So it says this, if you see here, it did something here, and it says traceroute this. You now use this redirection command to Cisco traceroute.txt. Then you now read it. So if you follow the assignment I gave, you should understand what's going on here. Say cat this to view the output and then understand it. So these are very, very important things. So please, if you while you are doing this lab, you have any issues, please don't keep quiet. You won't help yourself. All right. Always ask questions. So let's talk about communication protocols. Like I talk about protocols, you can either is a way computers use to talk to themselves. So in these protocol things, is either wired or wireless. And like I've explained, messages are usually encoded. You can see it here, it's talking about it. Protocols, these are 5 pillars by which protocols are. The message must be encoded. Before you build a protocol, you must talk about how do you encode the message. You must talk about how do you format and encapsulate. Encapsulate means how do you pack the message in a box, just like a delivery system. Talk about the size of the message, right? So in IP version 4, your message must not be below a particular size. When you get there, you will understand more about that. You also talk about message timing, so that the message does not stay in what they call an indefinite loop. If this message is not able to be delivered within so time, they tell the router to drop the message. And also talk about delivery options. How should we deliver the message? These are important foundations on which any protocol that is being designed is built. And there are many of such protocols. So, network protocols, message structure. So you see IP, this is IP data. Then path sharing. Let's talk about the path it will go through. So if you know about networking, you know that there are different ways. The path is not usually the problem. In a system where we have multiple switches, multiple routers, multiple devices that are sending messages, right? The question is, how does it know the path? So there are also protocols that are designed to automatically do that. We have what they call open shortest path protocol. We also have what they call border gateway protocol. We also have what they call EIGRP. There are different protocols for that, but those are advanced networking topics. It's not necessary for you in this class, but you just have to know those are what they call routing protocols. And then they also talk about information sharing. How is it going to share information? Then we also talk about session management. So like I was telling somebody today, clear your session cookies and all that. Session management, meaning that if this message is long, if this message is on, how long should this session be on before it goes on? Now, one issue in security is that if a session, for example, now we're on this call, and for this call to be on, a session has been established between me and everyone in this call. The same way from your own computer, a session has been established with you and everyone in this computer. It's that session that keeps this pipe of information I'm giving you alive. That's what they call session. So one mistake people that are designing these things make is that if we end this call, for example, the session should kill the call. Kill the call in such a way that anybody that clicks on this link will not be able to, if the person is not the creator of the link anyway, will not be able to see the call, will not be able to see the message. Though sometimes it depends on the configuration the person sets. Will not be able to join the call, or just tell the person, wait till the admin brings you back, that kind of a thing. That's a session. Session is very, 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 very important in such a way that once a link has been used, that's why whenever OTP is sent to you, or whenever a password reset link is sent to you, they will tell you that you must use it within so time. If you don't use it during that time, that link becomes invalid. You must get another link. Those are what they call proper session management. So that is very, very important. You keep the session alive. Just like you keep a time slot, you must do this within so time. So these are things they consider when they're designing protocols. So we have the TCP. TCP simply means Transmission Control Protocol, stroke IP suite. So protocol suites. And if you look at them, they operate at different levels. So we have what we call the network address layer. Right. So the popular protocols we have there are the app protocol, the Ethernet protocol, and WLAN. So the app protocol is what we call address resolution protocol. So app protocol is used in communication whenever you want to find a device. Whenever you want to find a device. I think I've said before in this class that IP address does not mean anything. What usually identifies you is your MAC address. So app makes use of MAC address very well, very, very well. When we get there, we'll explain all those app protocols. And then we have data link protocols. So data link protocols are protocols that help you to send data. So we have the Ethernet protocol. That one we used to connect cable, right? And connect cable to another one, to your own computer. That's Ethernet protocol. And we have the wide area local network. So the wide local area network. That's WLAN. So what WLAN is, for example, you're in a system of different computers. And you have to create a system of racks and switches and servers, and then configure that kind of wide local area network. Then we also have the main TCP/IP protocols are this one we have on the internet layer, the transport layer, and the application layer. So under the internet protocol, we have what we call the IP version 4, IP version 6, then the messaging protocol, ICMP, and all that. Then I talked about the routing protocols before. I mentioned OSPF, EIGRP, and BGP. Very, very important. Then the transport layer. Transport layer is what carries the information, right? So we have the TCP. For example, the ping we did use the TCP. The UDP is for the protocol that we are using to talk now on this call is UDP. It's what they call a datagram protocol. Very, very important. There's a difference between TCP and UDP. TCP, don't worry. Okay, let's not go into deep talking, so that we'll not waste that much of our time. Then we have domain name system, DNS. Very, very important. So DNS is it's just like a table, right? It's managed by a server, though. It's just like a table that resolves IP addresses to the name. So for example, we ping Cisco.com. Computer does not understand Cisco.com. What computer understands is IP address. So in DNS, on the DNS records, it has pinged Cisco.com to a particular IP address. So once you go and put cisco.com on your browser, the browser will now be like, I don't know what cisco.com means. It will ask the DNS, hello DNS, do you understand what cisco.com means? DNS will say, yeah, cisco.com means 124.124, just like that, tell it the IP address. Then your browser will now say, oh. Your browser will now go to search for that IP address. Your browser does not search for cisco.com originally. So that's the function of DNS. DHCP is Dynamic Host Control Protocol. We'll explain more about that, but what it does is that it automatically gives you IP address for you to connect to the internet. Then we also have email protocols, SMTP, POP3, IMAP, file transfer protocols, FTP, I've mentioned it. Then web service, HTTP. There are other protocols, thousands of them on this. You see this, bro? Thousands of them, but we're going to focus on the major ones that also there. And also, as you grow and you jam other protocols, you'll be able to understand. Oh, there is a complete explanation of everything here, so you can also read more and for your own personal consumption and understanding. So message formatting, like I explained, message formatting is the structure it's sent from the source to the destination. You just need to understand what structure does it take, right? From the source to the destination. That's message formatting and encapsulation, how it wraps data. Then message size, very important. Okay, these are concepts we've talked about in the building of a protocol. The size must be established. Nothing is random in this thing. We don't do any random things here. Otherwise, there will be problems. Then we also have message timing. It's very important for flow control. How fast does it go? Rate of data transmission. And if there's no response, how does it time out? It times out immediately. Then access methods. Very, very important. Access method. How is it accessed? Should you access via wire or wireless communication? So wireless communication happens because there's a control tower around you. Normally when there's a call made, the signal bounces from tower to tower to tower before it gets to you. And they also have what we call different types. We have unicast communication from one source to one destination. Multicast is from one source to many destinations, while broadcast is from one source to every destination. Different things. Unicast, one source to one destination. Multicast, one source to multiple destinations, maybe 2 or 3 destinations. Then broadcast to everybody. And broadcast is what app usually uses. So why are we using all this model? What's the benefit? So the benefit is just majorly to provide a common language. Like I explained, when Windows have their own protocol, these will have their own protocol, there was chaos. But now there's a singular protocol that everybody uses. It majorly provides a common language. That's for me, that's the highlight of the moment, right? Highlight of the moment. There's competition because different vendors can work together. Okay, that's also true. That's also very, very true. So please learn this OSI model. It's very, very important. In fact, go and research on it. What is the OSI model? Open System Interconnection Model. Please learn it. Very, 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 very important. And the TCP stroke IP model. There's a way it encapsulates. If you don't understand it, ask questions. Now let's talk about data encapsulation. So data encapsulation talks about how messages are sent. So sometimes when you are downloading anything, you discover that you are downloading a file of 3.8 gig. 3.8 gig does not just enter into your computer at the same time. Bam. That's not how it works. So what it works, it starts by segmenting it, breaking it down. The download comes small. So that's how it works, right? Comes small. Because imagine that you want to download a file of 3.2 gig and the pipe that file to pass through is 100 MB. 3.2 gig, if you want to put everything through that pipe, it will not work, it will fail. So it will break it down into chunks and be passing it in stream. So that's why a protocol is needed. Protocol is needed in such a way that it's going to know the first message to send that it sent and the last message that it sent. each of those information is carried along the pipe. So when it gets to your computer knows the first bit of data that came in and knows the last bit of data that came in and knows them in their order. So your computer is going to follow that order and compile the whole file back together and give you the original message that was sent. That's just the whole idea here, right? Encapsulation. So as it's sending it, it's encapsulating it. That encapsulation is adding data under it. When it gets to the other end, it does what they call de-encapsulation. It removes the data, does what it's supposed to do, and give you what you downloaded. That's just what happens when you have when you are doing downloading. And if you are careful, you observe that smaller files download faster than larger files, right? But the speed of download of larger files is higher than the speed of download of smaller files. So if you're downloading like a file of, let's say, 5.4 gig, and you're downloading another file of 200 MB from the internet space, you will discover that the one of 200 MB may be downloading at the speed of, let's say, 2.1 kilobytes per second. I'm just giving for example. Meanwhile, the one that was higher file size is downloading at a speed of 2.4 MB per second. I don't know if any of you have gotten the internet speed before, but it will be very, very interesting internet speed. 2.5 megabyte per second. And it's downloading. It's just a computer thinking, or your internet, the protocols thinking. Logically, of course. Since this file is larger, it should have a higher download speed. So your protocol just allocates a higher download speed to that one and gives a smaller file a smaller download speed. It's just thinking, basic thinking. So these protocols are designed for that, right? So that's just the basic idea of data encapsulation, right? Wireshark. How many of us have downloaded Wireshark? Let me know. How many of us can use Wireshark? Joy, can you use Wireshark? Can Joy use Wireshark? Zara, you can use Wireshark. Zara, please unmute your mic. Where do you work, Zara? Are you a hacker? Let me know. Let me know who I'm dealing with.
No, sir.
Are you a hacker?
I'm no, I'm a network engineer.
I can use
You're
to
a network
analyze
engineer. Where do you work?
I work with Cisco partner company here in Lagos.
Wow, Cisco partner. Which of them? I know some of them. Which of them?
One at Lekki, PIIT.
PIIT.
Yeah.
That's new to me. Muritala, you were saying something. You know how to use Wireshark. So you guys use Wireshark every day now. You're always checking the signals, seeing where it's coming from.
I use it. I use it in the network
Okay,
traffic.
use it.
Yes, a network traffic analysis.
Yeah.
I can use to capture it.
Someone is saying something also.
Yeah, okay.
So Wireshark captures everything.
Yes,
Right?
DNS, TCP, HTTP,
Yeah. You just have to specify the interface. It will capture everything going through. So that's why we tell you guys, when you go to an airport and you see free Wi-Fi, can you just mind your business and leave it alone? Don't connect. Don't connect. Leave the free Wi-Fi alone.
Not just
You can imagine that.
airport.
I said anywhere.
It's not just
It's not
airport. Hotels.
Yeah. Anywhere you go, you see free Wi-Fi. Leave it alone. Leave it alone. I have simulated real attacks. And I'll just say, look at somebody's password to his bank app. I'm telling you. Password to his bank app. And I'm like, wow. So that's where what we're talking about comes to play. Discover that the overarching quality you have here is your ethics. It's your ethics. The things that we attackers see every day, implement it. Some of us would have made money using dubious means. But then that's not why we're here. We're not here to steal money. So you're not sure of any network. I can just come to a hotel now and say, okay, I'll come online and check. Okay, what is the Wi-Fi name of this hotel? The hotel is so and so. And I know that the Wi-Fi name is free. You know what I will do? I will go on my machine and send what they call the authentication signal to that hotel's Wi-Fi. That hotel's Wi-Fi will go down. I will put my own Wi-Fi with the hotel's name. So imagine that you are browsing. The hotel Wi-Fi have gone down. You now come online. Okay, it's back up again. You don't know that hotel Wi-Fi is still down, but the Wi-Fi you are seeing now is a fake hotel Wi-Fi. And you connect, and I now connect my Wireshark. All the traffic, everything you are browsing, I'm seeing it in real time as you are pressing, as you are visiting that site. So imagine that site now is not using HTTPS, it's using HTTP, and it's not asking you for username. I will see it. Some of them that use HTTPS, the way they implement it is wrong, and when they implement it wrongly, we can downgrade it. We can downgrade it and still see what you have done. Though downgrading is illegal anyway, but it can be downgraded. So that's the problem. So you have a work to do with Wireshark here, right? I have Wireshark, for example, on my computer, on my Windows here. Let me open. So Wireshark can work both in Windows and you can see it here. It has this symbol of the fin of a shark. So let me open it. We can just test it and see. Augustine, I saw your hands up. I'm coming to you. So can just open it. Then to ask us which module do we want to use? Do we want to check? Since I'm using my own personal Wi-Fi, I think we can check. So he's asking me, where do you want to capture? Remind me later. We'll download that version of Wi-Fi. So where do I want to capture? Let me use my Wi-Fi. So because all my network is flowing through my Wi-Fi now. So I want to capture my Wi-Fi. What's this? Start capturing. You can see a lot of things is going on. See, it's capturing packets, right? So you can just stop it. Say you're not capturing again. See now, within this moment now, over 5,000 packets have been captured, and some of them have application data. If you look at it, you see. But there is a TLS, Transport Layer Security version 1.2, so you can't see anything from it. If you open it to see the main information, you will see gibberish, see nonsense inside it. From there, if you are going through Wireshark, you can see the source port, the destination port 443. So meaning this is a web, something that's happening on the website. All these things have meaning, but you understand the meaning when you talk about IP version 4, right? You understand the meaning, what they actually mean. This is IP version 4 protocol. So of course 0100 means version 4. Remember when I was saying something about, in our last class, I was saying something about permissions, and then we mentioned something about binary, right? And then I said 100 means number 4. That's what it's just saying here, right? 0100 means version 4. Then there's also another one called 0101. It's trying to tell you the header length. All this is a standard header length. If you look at the end of the day, you can see the information by the right hand side here. It's rubbish you are seeing here. Why are you seeing rubbish here? Because the protocol that was used here is protected protocol, is encrypted protocol, is a secure protocol. If this is not a secure protocol, you will see what was sent in plain text. You will see what was captured in plain text. Let me see if it captured anything. Let me see if I can filter something here. Let me say HTTP. Let me just say it should filter only HTTP. There's no HTTP, so nothing to see here. So it did not capture any HTTP request. If it captured any HTTP request, we'll check, we'll see the information in real time and see what was captured. The same way, though WhatsApp has started implementing security, you should also know that your WhatsApp calls could be captured. Yes, and Wireshark will play the voice notes. You are doing a WhatsApp call. If you are doing it via an unprotected network, it's going to, someone can capture it and play it. That's what happens. Sometimes you say, people went for protests and they did not arrest anybody that did the protest. They arrested another celebrity that maybe you did not even notice in that protest. Why? Because they were able to capture them. They were able to know the people that are sponsoring that protest. Maybe the protest is anti-government or something like that. That's why most people that are doing protests, when they want to do all those protests, they keep their phone at home. Because you are saying, we are going to storm the capital of this country now. The government is saying, and the government is trying to know who are the people that are planning this protest. How are they getting money? They don't know. They will allow you people to do the protest. But that day you came to do the protest, they've planned for you. There's a device called Sting. So they put that device within the vicinity where people are doing the protest. So what does Sting does? Sting will go there and disable all the cell towers. So if you are saying, Sting will disable all of them and become the cell tower through which everybody's network will pass through that day. And there's a Wireshark at the end, capturing everybody's traffic, capturing everybody's details. So all the people that came there and was posting selfie, they are seeing everything you are doing. So they are watching you. But you are not their main concern. You are not their main concern. They are looking for somebody. They are looking for somebody. They want to find the people that are doing the actual thing. And when they catch them, so the main organs don't come to those areas with their phone. Or they come with a phone that has no information. Because in the process of capturing it, they're able to know more about that phone. And from knowing more about that phone, they can know what is happening. And if they capture it and then they look, oh, Mr. President, this is what we discovered. And Mr. President, that boy is a threat. And carry him. They will carry you. So that is just one of the things you need to know. Wireshark is a very powerful tool. It is free, open source, right? It is free, open source, meaning you can use it, enjoy yourself, and as my friends will say, flex, right? Flex. So, like I said, I will not. This network topology is already in Wireshark, and trust me, it is self-explanatory. I've done this experiment before on Wireshark. If you press this password, this command given to you here, this is the Python file already, topo.py. It shows you the topology of the network. So the topology of the network is just like there is a computer 1, computer 2, computer 3, and all of them are connected to a switch. Why this router serves as the gateway to another computer. So this H4 here is a computer on the internet. So we want to know if there's a route majorly to this computer on the internet. Or maybe when you are doing something here, you want to capture the ping. So ICMP traffic is just like ping traffic. So I think that's just the major thing you will do here. You will understand what's going on. You're also going to get the MAC address. Of course, MAC address is here in this Wireshark capture. You can always see MAC address too. MAC address should be somewhere here. That shows the MAC address of the device. So that's why anything you are doing on the internet is not hidden. It's not hidden. It's very, very open. Right? I think where will I see MAC address? See, there's a MAC address here. Are you seeing device? You can see device ID 0. You can see the MAC address here. It's there. Right? The MAC, everything is here. It's not hidden. It's just there looking at you. And there are informations about the MAC address that are very important. For example, MAC address is usually 12 characters. The first 6 characters, the first 6 characters tells you the manufacturer. For example, they have a MAC address here, BAD41D. I can just copy it and paste it on the internet. I will see the manufacturer of the device. Let me see. I can paste it on the internet. You can see MAC address vendor lookup. So I can go click on this website now and then check MAC address vendor lookup. So if they say paste it, you don't even need to paste everything itself. Let me just paste the first 6 and let's search. Okay, it did not see it. Okay, see type of system. Okay, we are seeing Wireshark here. Hold on. This was gotten from this lab. If it's a valid MAC address, we'll see it. And most of these tools are free. Very, very free. You know, you're not paying anything. So if we search for this MAC address, you see no assignment is found for the MAC address because this is just a fictitious address, right? It's a fictitious address. Hold on, let me look for MAC address. Let me see. Let me get a correct MAC address. Let's see something that should show us. That should show us. Let me see how to find my MAC address. So let me, for example, if I say if I say IP config, let me use /all. I want to see if I can see my MAC address. Okay, so there are a lot of MAC addresses here. Okay, let me just pick any MAC address for any place I see here. So you can see this is Ethernet adapter. This is physical address. This is your MAC address. So if I copy this MAC address now, and I go to that site and I paste it, let's see whether I will see something about it. Let's search this. Are you seeing? It's telling me that this belongs to what? HP, Hewlett Packard. It belongs to HP. So they are different distance, right? The first 6 digits is what we call the OUI, organization listing. So you can even check more. You can even see details. Details is showing you OUI. OUI has ATE82C, and then it shows you the range. It shows you the block size. So anything they have, it belongs there to them, right? Hewlett Packard, HP. So they are different. They are different ones. So if I check now, okay, in that command I wrote, there are also other IP MAC addresses again. So that this one is from Ethernet this thing. There are also other MAC addresses there again. Let me see another physical address. There's also another physical address here again. Let's know whether this one still belongs to HP. But you can see that the description is VirtualBox host only adapter. But let us see whether it will tell us something that it belongs to VirtualBox. So these are part of things you do as someone that's maybe a SOC analyst, someone that's going into investigation, you want to know, right? You see, it says no assignment found. Do you know why no assignment is found? Because like I said, this is a VirtualBox address. It's a VirtualBox address. And VirtualBox is virtual, so it's just randomized. It belongs to nobody. Now, there's also another one. This one now is for wireless LAN adapter. It's for Windows. This is Microsoft. Let's see whether it belongs to Microsoft actually. So if you copy this and you paste it here again, it's telling you Intel. So what this actually means is that Intel actually manufactured it for Microsoft. So Intel is the original manufacturer of the wireless card that I'm using, but they manufactured it for Microsoft. So these are things you need to, learn how to check and learn how to use. So I think we'll come to the end of this lecture. Does anybody have any question? Any question at all? Any question at all? You don't understand something, or maybe you don't understand what to do. This is module 5. We are in our 3rd week, right? After our 4th week, you have 1 week of rest. So we're in our 3rd week. So if you have any question, please drop it. Let me hear. Yeah, 2 participants have raised their hands.
Okay.
Yeah. Adekunle, go on.
Yeah. Thank you very much for a very good, well-delivered lecture. In fact, you are making my mind to be restful at the same time and thinking very wide. Say right now is from all your lecture is good for us as a cybersecurity learner to be working as a team, because I don't think one will be able to wants to remember everything he wants to do when he's trying to lay on a particular maybe investigation or whatever. But maybe we are like 2, 3 working together, doing things together. I think putting ideas together to be more easier. I'm just thinking that just I should confirm that. Can somebody do it individually or in as a team would be more easier?
So, me, do you know what I suggest? You you can learn on your own, but working on the team is a very good skill you need. Please, you need to know how to work with a team. Someone like me, I'm a solo learner. I learn fast on my own, right? But I will not suggest that. If you know you're not understanding anything, don't keep quiet. Look for somebody you can learn with. And also another way to learn is that you see somebody ask a question, try to solve it for the person, right? Try to teach. When you try to teach, you are only forcing yourself to learn. And if you teach one particular concept over and over again, you're going to learn. Now, the idea of working together as a team or whatever, we're going to look into that. It's not up to me to make the final say. Maybe we'll give you guys something that you do as a team. A lot of assignments are bound in that regard. A lot of things to do are many there to work as a team. Sure, we can create something like that for you people. But I don't have the final say in that aspect, honestly. But we'll get back to you people on that request. Yeah, Augustine. Okay, Augustine's hand is down. Ayodeji, you want to ask something? Your hand is up.
Yes, sir. Can I say something now, please? Thank you.
Augustine, go ahead. Oh, you've been dying to say something. Sorry.
Okay,
Please.
thank you so much. I got an answer to my question the first time. That was why I had to bring down my hand. So thank you very much for the lecture
Oh,
so far. But please, I
yeah.
want to say that you are a bit very professional in terms of your explanation. It's not really for beginners. You understand? Like the wire shark and everything. You know, first of all, before using a wire shark for a beginner, there is a way to go about it to constitute um those laptops and all of that. So I think you are supposed to help us, look at the Wireshark environment, tell us stuff and all of that, how to simulate, how to do this in real time. So that somebody that is a beginner can have an idea
I
because you are a
understand,
bit
right?
very yes,
Yeah,
sir. So
yeah,
please,
yeah.
I need you to
I get your
answer a
point.
bit.
I get your point. I get your point, but
Yeah,
you should know that
thank you.
one of my major challenges is time. I'm a sticker to time. If I start doing that now, it's gonna be problematic. I don't want to keep you guys beyond the time I said I'll keep you.
And we are not complaining. Sorry, we are not
No,
complaining. We just want
no. I know you want to stay here. I know you have all the day, but everybody does not have all the day, and we have to be on one page, right? So that's why we encourage you to learn and ask questions, right? We encourage people to sit on their own and learn and ask questions. Honestly, I can stay and start telling you one after the other, one how to use Wireshark, how to even download it. I'll sit with you. We can do that, but then we don't have all the time. That's just the main restraint. I understand that you have all the time, but not everybody has the time. So we have to consider every other person. Is that clear? It does not take me anything. I can break down concepts into simple things, but we have to make use. We still have constraints, and we have to work with time. Time is very important. I don't want to spend 1 minute higher than I'm supposed to spend. Yeah, Ahmed Muritala, you have a question? I see your hand up.
Yeah, thank you for the interesting lecture delivered by you. We really
Yeah.
appreciate. My question now is that as a cybersecurity expert, maybe you are hired by an organization or company to investigate in any data breach or vulnerability. For example, now on
Yeah.
Kalinos, we have a lot of tools on there, and as a cybersecurity expert, you need to combine different tools for any investigation, maybe data breach or vulnerability. So on O system, is there any app that houses all these tools, like different tools, or we need to have individual tools on the system downloaded, or can we use what's it called, virtual tools to make our investigation in any vulnerability when hired as a cybersecurity expert? That's what I want to know. Or it can be, or there is there an app that integrates all these apps? You know, on the Cardinals, we have Hydra, we have Bloodhounds, we have Wireshark, everything hosted on the Kali. So, do we have any host app that integrates all these apps together for any cybersecurity investigation? Thank you very much, sir.
Okay. I think you're asking the wrong question. You're asking the wrong question. So whenever you are giving in a proper setting, nobody cares about the tools you are using. You understand? In real life, nobody will send you. Nobody is interested about that. All they want is get the job done. Right? But then if you don't know how to use these tools, how do you even start? Really, like Zara now is working with Cisco somehow. No, but they don't really care. All they're after is, did you get the answer? Yeah, get the answer. Okay, that's the end of the day. I work with a telecommunication company. My methods are not really the problem, though in some cases my methods can be a problem anyway. But in 85% of the time, the tools I use are not really the problem. What is the problem is you having a fundamental understanding. So I would suggest that you should not think about the tools more. I'm speaking from experience. If your mind is always about the tools, you will have the tools and you will not know how to use them. Right? So there's that breach. I have the tools. Do you think that there's a tool that will tell you where the data breach started from and where it ended? No, it's most likely a thinking thing, and that thinking comes with experience. For example, now I got a mail from Zenith Bank today. I don't know how many of you got that mail. That hey, there's a breach. I don't know. Did anybody get that same mail I got? That there's a breach.
Yes, I got it.
Exactly. People got the mail. So
Yes.
Zenith Bank has acknowledged. Yeah, Zenith Bank has acknowledged that there's a breach. So if they call me to investigate that, is it about tools? It's not about tools. You don't even think about tools first. You start asking yourself certain questions. Okay, there's a breach. What? When? How? These are things that should come into your mind. Then you come into the system. What do people have? What was breached? Where did it happen? So when you start asking yourself those questions, you discover that maybe at the end of the 70% of what you will do will involve no tool at all. Maybe when you have gotten some facts, then you now say, okay, you now want to check how it went from here to here. That's when you need a tool. Maybe you want to create a story. That's why you need a tool. Because there is no singular tool that you will put that will tell you how a breach started and ended. Is never there. You just have to understand. And if you're able to think and trace breaches, like you're giving me, for example, you're able to think, have the make basic mentality on how a breach can possibly occur.
Okay, sorry,
Right?
sir.
So if you
Sorry
think
for
and
cutting
see,
you short. Okay, what you are trying to say that we should focus more on reconnaissance as a network reconnaissance and incident as in
understanding
findings.
networking, understanding how securities are implemented in networks, and how it can be breached. When you understand these things, the tools are not the problem. At the end of the day, it is still the human being behind that does the main work. So that's my say. So a lot of tools exist and all of them do the same thing. For example, you're mentioning Bloodhound. Bloodhound is for Active Directory. That one I know how to use that one. But then how does Active Directory even work? Do you know where it is working? Where do you use Active Directory? So that's just the thing. So this is 7:54. I believe we are all no more question. I've not seen anybody's hands raised up. Like I've always said, please ask your questions. Speak up, say whatever you want to say. If you don't ask questions, you will not get answer. The Holy Book says, ask, and it shall be given unto you. Seek, and you shall find. Knock, and the door will be opened unto you. Say, the person that asks is the person that what? Thank you very much. So please, at this juncture, we can end this call and call it a day. Our next class will come up on Saturday by 6 p.m. I think we're going to be talking about IP protocol majorly on that. All right. Thank you very much.
Thank you very much.
Thank you.
Yes,
Thank you for the invite. I appreciate it.
Thank you, sir.
You're welcome. All right. I'll end this floor now.